Graphing polynomials. Let's start with vocab. Consisting of several terms, an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable. Location principle. Suppose y of f of x represents a polynomial function and a and b are two numbers such that f of a is less than 0 and f of b is greater than 0. Then the function has at least one real 0 between a and b. Relative maximum. A point on the graph of a function where no nearby points have a greater y-coordinate. Relative minima. A point on the graph of a function where no nearby points have a lesser y-coordinate. Extrema. The maximum and minimum values of a function. Turning points. Points at which the graph turns. The location of relative maxima or minima. In behavior. The behavior of the graph as x approaches the positive or negative infinity. Zeros of even and odd functions. Odd degree functions will always have an odd number of real zeros. Even degree functions will always have an even number of real zeros, or no real zeros at all. 0. The x-coordinate of the point at which a graph intersects the x-axis. Infinity. Endless or boundless. State the degree and leading coefficient of each polynomial. 7x to the 4th plus 3x to the 7th minus 2x to the 8th plus 7. First we need to arrange the numbers in decreasing exponent order. So we have negative 2x to the 8th plus 3x to the 7th plus 7x to the 4th plus 7. The degree is the highest power or largest exponent in the equation. In this case, the highest power would be 8. The leading coefficient is the number or coefficient in front of the largest exponent. Here the leading coefficient would be negative 2. Example 2. This problem we are going to be graphing the equation by using a table of values, stating the domain and range and stating their relative minimums and maximums. The equation is f of x equals x to the 3rd minus 5x squared plus 3x plus 1. We'll start off by drawing the table. In the middle of the x side we will put 0, then negative 1, negative 2, negative 3, and negative 4 going up. On the bottom side of the 0 will go 1, 2, 3, 4, and 5. To find the y values, you will need to plug in the x value into the equation and your answer will be your y value. Let's start out with the x value 0. When you plug that in, you should get 0 to the 3rd minus 5 times 0 to the 2nd plus 3 times 0 plus 1. You would put 1 into the y side by the 0 on the x side. This is your y-intercept. Now repeat the same process but with 1 instead of 0, or negative 1. Your answer to this will be negative 8. And that goes in the y side by the negative 1 in the x side. Repeat this process for the remaining x values. You should end up with y values starting from the top, negative 155, negative 80, negative 33, negative 8, 1, 0, negative 5, negative 8, negative 3, and 16. Now you can begin to graph your equation. Simply place the dots on the graph according to each coordinates on your table of values. Since negative 155, negative 80, and negative 33 are very high, we cannot plot them and leave them off the graph. Now you connect the dots with a curved line. You can see the high and low points now. The relative maximum should be 1 because from what we have graphed, it is the highest turning point. Our relative minimum would be negative 8 since it is the lowest turning point that we have graphed. The domain would be all real numbers, which can be expressed with an r with a line through it. The range would be y is greater than or equal to negative 8 for what we have graphed. Now we are done, but if we wanted to, we could also state the ending behavior, which would be as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. Example 3. Here we see our two graphs and we are to describe the ending behavior, determine whether it is an even or odd function, and state the number of real zeros. Let's begin with a. We can see that as the x-axis approaches positive infinity, f of x approaches negative infinity. Now we see as the x-axis approaches negative infinity, f of x approaches positive infinity. We can also see that this has an odd degree because the arrows are going in opposing directions, and there's an odd number of turning points. This only passes through the x-axis once, so that means that there is only one real 0. Looking at graph B, we'll start off finding the ending behavior. As x approaches positive infinity, f of x approaches positive infinity as well. and as x approaches negative infinity, f of x approaches negative infinity. This graph has an even degree because the arrows point both in the same direction and there is an even number of turning points. There are no real zeros because the graph does not go through the x-axis. Example 4. The number of subscribers using pagers in the United States can be modeled by f of x equals 0.015 times x to the fourth minus 0.44 times x cubed plus 3.64 times x squared minus 2.7x plus 9.68, where x is the number of years after 1990 and is the number of subscribers in millions. A. Graph the function. B. Describe the end behavior of the graph. C. What does the end behavior suggest about the number of pager subscribers? And D. Will this trend continue indefinitely? Explain your reason. For A, you construct a two-column table labeling one column x and the other y. You then start selecting potential values of x and plug that value in wherever you see x in the equation. Then simplify the equation and put this value in the y column. Since the degree of the equation is 4, you continue forming the table until you see 4 changes in direction. You can also put the equation into the y equals function on your calculator and then hit second table. You then take these points and graph them. Look at your graph. You can tell by the degree of 4 that this polynomial has an even degree function. This means that as x approaches positive or negative infinity, f of x will be approaching the same infinity. Now look back at your graph. You will see that as x approaches positive infinity, f of x will also approach positive infinity. And while x approaches negative infinity, f of x will also approach positive infinity. This is the end behavior of your function. C. Even though pager sales sometimes have dry spells, they are generally on the rise. Now, taking into consideration that your graph shows sales as generally rising, this means that even though pager sales have endured some dry spells, they are generally on the rise. Given that you can only predict the future, pager sales will not continue on this trend indefinitely because it doesn't take into account the possibility of new technology being developed that would lower the popularity of pagers.